Alright, ladies and gentlemen, today you'll be taking some notes and doing some sample problems. If I'm asking you to do a sample problem, I'm expecting you to actually do the problem, calculate it on your own, and then compare with what I tell you on the screen. You will be handing this paper in at the end of the period. Alright, so let's start off with talking about kinetic energy again. The other day we talked about kinetic energy, and as you can see on the screen, we have the same notes up here, where kinetic energy is equal to 1/2 of the mass times the velocity squared of an object. Let's first question. If I give you a bowling ball that has a mass of 7 kilograms, and that bowling ball is traveling at 3 meters per second, I want you to calculate the kinetic energy of that bowling ball. Go. Are you calculating it on your paper? I hope so. In the future, I'll be pausing the video during your calculations. So you got that, and you get your calculator out. Have you got it figured out yet? Let's see. 0.5 times 7 times, I'm going to go 3 squared and say 9 equals, I have an answer on my calculator that may be hard for you to see, of 31.5 joules. There's our answer. Okay, next question. Let's say you're bowling with your friend and you want to see who can throw the ball faster, and you want to calculate the kinetic energy of your ball. Let's say that the bowling alley has a computer system that actually will tell you the speed of your ball. So let's say instead of bowling it at 3 meters per second, your friend is strong enough to bowl it at 6 meters per second. Go ahead and recalculate the kinetic energy of this bowling ball while it's being thrown down the lane. Your substitute will pause the video while you calculate, and I will give you 5 seconds before I start revealing the answer from right now. Alright, time to calculate for me then to show you the work. Again, 0.5 times 7 times, in this case, 6 squared, which is 36, equals, I have an answer. You may not be able to see it on that small calculator. I got an answer of 126 joules. So this is what happened. What effect did we have by doubling the velocity of the ball? How much bigger did our kinetic energy get when we doubled the velocity of the ball? Figure out by what factor the velocity got bigger. Go. Hopefully your calculator showed you when you divide 126 by 31.5, hopefully your calculator showed you that the energy was 4 times bigger. This is because of the squared. It's because of that squared right there. Anything you do to the velocity squares the energy. Well, let's bring the speed back down to 3. What if, in trying to show off, you, instead of having a 7 kilogram bowling ball, you go to the rack and you hunt around until you find a 14 kilogram bowling ball. You're really trying to show off for your friends. Now go ahead and recalculate that energy. Again, I'll give you 5 seconds you can pause the computer, and I'll give you 5 seconds, and then I'll start calculating it with you. Alright, time for me to calculate. Let's see, 0.5 times 14 times 3 squared, which is 9. So times 9. And I hit enter, and I've got, in this case, I've got an energy now of 63 joules. Now, when we compare the difference there, original with a 7 kilogram ball was 31.5. Now we have an energy of 63 joules. Real quick, figure out the difference between them. Go ahead, calculate it, put it on your paper. And you have found that by doubling the mass of the ball, we have gotten double the energy of the ball. That's right. The big point I'm trying to make is this. If you change the mass, the energy just changes by however you change it by. If you double the mass, you double the energy. If you cut the mass in half, you cut the energy in half. However, if you do something to the velocity, that what you did to it is squared, and that is the big effect. Alright, let's move on to other problems. Potential energy. We did some potential energy examples earlier. Well, now let's do another sample problem where you're going to write on the paper, Bob, instead of diving off a nice simple 5-meter board, Bob is instead really putting himself out there. He's going to jump off an Olympic 10-meter diving board. I want you to calculate Bob's gravitational potential energy as he stands on top of the 10-meter diving board. Go. You can pause the recording again. Alright, so we took in here 100 kilograms times 9.81 times 10 meters. So 1,000 times 9.81, 1,000 times 9.81, and we got 9,810. Easy enough, right? 9,810 joules. 9,810 joules of potential energy. Well, now let's really put this into practice. And let's talk about a new topic here. A topic known as mechanical energy. Now, we've talked about mechanical energy in class in our vocabulary. Mechanical energy of an object is equal to the sum of the kinetic and potential energies of the object. So at any point in time, something that is moving could have both kinetic and or potential energy. And it could have gravitational potential energy, or it could have elastic potential energy. And for that matter, it could have all three. I'm not going to give you a problem where you're figuring out all three. But you very well could have to figure out the kinetic and the potential energy, gravitational, of an object very easily. So that's our big idea right there. Give you guys time to write. If you need more time to write, go ahead and pause the recording, so you have time to write that down. All right, let's do another sample problem. Here, Bob has the unfortunate event where he is falling off of a bridge. Let me lay things out for you here. The bridge is 50 meters tall. Bob has fallen 20 meters. I want you to figure out Bob's mechanical energy at this point. After falling 20 meters, you need to figure out his mechanical energy. To do that, you're going to need to find his kinetic energy and his potential energy, gravitational. You might say, I don't know how fast Bob is going. There's an equation that we have that works like this. The velocity you want squared is equal to 2 times g, 9.81, times the height that you have fallen from. Bob has fallen 20 meters. So you put 20 meters in. 20 times 2 times g, and then you take the square root when you're done. That'll give you the velocity. Given this information, I want you to calculate Bob's mechanical energy. Go ahead and pause the recording so we can calculate that. Go. Alright, I'm going to help figure out the velocity here in case you haven't gotten that right. We'll make sure that you are correct. So we got to go 2 times g times the height. So 2 times 9.81 times the height of 20 meters that he has fallen from. I got 392.4. I need to square root 392.4. So put that to the 0.5 power. And I got almost 20 meters per second, 19.8 meters per second. So let's jot that down here. A color that'll show up. 19.8 meters per second. Now, let's calculate the kinetic energy together since I have that working here. To do the calculation, I'm going to put in 1/2 times 100 kilograms times this squared. Well, we just had that squared at 392.4. So, on my calculator, I'm going to square that again. Squared 392.4 times 100 times 0.5. And I've got Bob having a kinetic energy of 19,620. 19,620 joules. Did you get that? Circle it if you got it. If not, make sure you're writing down what we did. Now let's do his potential energy. So 100 kilograms times 9.81 meters per square second. I'm not superscripting that. Times, now here's height. Now here for the height, we need to look at how high above the water is Bob currently. If he's fallen 20 meters from a 50-meter bridge, his height is here at 3 meters. That's Bob's height. So let's plug that in. And not 3, oh my goodness, 30 meters. Put that in your calculator if you haven't done it already. 100 times 9.81 times 30. And this comes out to 29,430. 29,430 joules. That was a fun problem, right? Hooray, yay. In the next video, we'll calculate his mechanical energy at the top of the fall and his mechanical energy at the bottom of the fall.